right, for the next notes, continue on in volume for section 12.5, we are going to today look at the volume of a pyramid and a cone. So we are grouping, we're going from prisms and cylinders to pyramids and cones. For the first part of this, we always start with the volume formulas. And in order to give you some understanding of where the volume formulas come from today, we are actually going to watch a little video. So to set up the video, what you're going to see when we get to this video is you are going to see a pyramid and a prism. They both have a square base. And so if I were to outline it, we can sort of see the square bases right about here. And those bases are exactly the same size. So if I were to put the prisms next to each other, they are going to have the same height. They're going to be the same distance tall, so the same height. And then the bases, if I were to put the triangle, the pyramid on top of the prism, the base would completely cover the base of the prism. So these have the same base and they have the same height. So the relationship that I want you to think about is as we go into volume, I can't really as easily take cross sections of this. It's just going to be either squares if I go parallel to the base, and they're just going to get smaller, and stacking those is going to be weird. So the kind of sliced bread idea that we did yesterday does not work quite as well. So here is your challenge. My question for you is I would like you to predict how many pyramids you think it would take to fill the prism with the same base and the same height. So I want you to think about how many you think would fill this, how many would fill it. Prediction. I want you to just write it down. So maybe write something like, I predict blank cones, or sorry, these are pyramids, blank pyramids to fill the prism. All right, so write down your prediction, and now that we are ready to go, we are going to switch over and watch the video. Now, there is not sound behind the video. All we're going to do is watch it. So watch and see if your prediction is true, and we'll see how good our guessing skills were, and then we will meet back after that. Overestimate? Did you underestimate? Here is what we figured out. That the video showed, and the person who filmed this video did a pretty good job of it. It took 3 pyramids to fill up that prism. And so they had the same base and the same height. So here is what this means for us. The volume of a pyramid that has the same base area, the same height, ended up being 1/3 of the volume of the prism. And so this is really helpful when it comes to our area formulas because I already know the volume of a prism, so I don't have to go and invent something unique and special. I just can take that number and multiply it by 1/3, and that comes out to be our volume formula for a pyramid. So for a pyramid, the volume is equal to 1/3 capital B, the area of the base, times the height. And so as a reminder, here we'll put this just so that we have it. B is equal to the area of the base. We keep that general because it can be a square, triangle, any sort of polygon shape here as the base. And then the height in this case is the distance from the vertex to the center of the base. That is this segment that I have just highlighted, and that is H. So before we were using slant height for surface area, now we're using the actual height if we were to measure how tall it is from the bottom floor up to the top, what that is. And so that is our volume formula for a pyramid. We'll write that here. So now let's move on to the cone. So for the cone, if we were to watch, the same thing is going to happen. If I had a cylinder that had a circular base that was the same base length as this cone here and the same height, the cone it would take 3 cones to fill up the cylinder, and so the volume of this cone is 1/3 of the volume of the cylinder. So we're going to give some important factor or some important naming here. The base of this circular cone has a radius of r, and the height is h. So if we go back over to our volume formula, volume is 1/3 area of the base times the height. Well, the area of a circle is pi r squared, and that is our base. So for the volume of a cone, we can replace this, and this is 1/3 pi r squared, which is the area of the base, times h, and that is the volume of a cone. So let's go ahead and look at some examples. Number 1 here. The base of a regular square pyramid has a perimeter of 120 and a lateral edge measures 25. Find the volume of the pyramid. So first, let's go ahead and draw this. Hopefully at this point you feel like you're getting better at these. So I usually draw a parallelogram. And then I usually would go up from there and then connect to that point. All right, important idea here is it is a regular square pyramid, so it means that the base is a square. Perimeter is 120. Now remember, that is not area, so I need to figure out what the length of the side of this square is. Since it's got 4 equal sides, we can divide 120 by 4, and that gives us that each side length is going to be 30. So all of our sides are congruent here. So important pieces that we need as we go about this is we need to know what the area of our base is, and then we need to know what the height is. Now we have yet to draw in the height. What I would encourage you to do is to draw a dot in the middle of the base and connect that to the vertex of your pyramid. So that is our height. Even if you're not an artist, the great thing about Notability is it allows us to draw pretty good shapes here. Okay, so area of a square is side squared, so that would be 30 squared. And 30 squared is 900. So this base has an area of 900. Now we just need to find the height. So next up, it tells us that the lateral edge measures 25. So let's use blue. And so that's one of these sides here is equal to 25. So here's what I would encourage you to do. We actually haven't seen a problem like this in a while, so I'm going to walk you through it. We want to make a right triangle with this height. The best way to do it is connect it along the diagonal of the base and form a right triangle this way. So what happens is once we have formed this right triangle, if I think about extending this diagonal, because this is a square, it forms two 45, 45, 90 triangles. That would make the entire diagonal 30 root 2, which, if I cut that in half, makes this diagonal come out to be 15 root 2. The Pythagorean theorem would also get that for us here, but that makes this diagonal come out to be 15 root 2. So then now what we want to do is we want to figure out the height using Pythagorean theorem. So at this point, I know it's kind of hard to say, I'll use an arrow. We'll call this h. So that makes h squared plus 15 root 2 squared is equal to 25 squared. So then now that makes this h squared plus, and then if you're not sure how to do this, you can put 15 square root 2 in parentheses and then square that, which gives us 450. Or the trick is we square the first number, 15, we multiply it by the number underneath, times 2. So that gives us plus 450 equals 25 squared, which is 625. So that gives us h squared is equal to 175. And then as we go to square root this, we can make a factor tree. I think of that as 25 times 7. Let's just double check that here. 175 divided by 25. Yeah, 25 times 7. So that's 5 and 5. And so that makes our height, keeping things exact. We're in honors geometry. We want to keep things in square root form. This is 5 square root 7. All right, so not a lovely number, but it works. Our height is 5 square root 7. So now let's go to volume. The volume of our pyramid now is 1/3 area of base times height. So it's 1/3 of 900 times 5 root 7. So we only want to do 1/3 once. 1/3 of 900 is probably our easiest one. That becomes 300 times 5 square root 7, and that becomes 1,500 root 7 cubic units. And that is our volume. So hopefully that shows you how to use right triangles, how to use the volume formula, and a nice review of square roots and Pythagorean theorem. So let's go ahead and look at this next theorem that we have ahead of us. Okay, so we'll get into a couple more examples, but right now, with our volume formulas, we also need to go back to what we did with the cross sections. So here we're talking about a pyramid or a cone. When we take a cross section at any point, like what is shown in this shaded piece, if we look at what shape that cross section is, that cross section is also going to be the same shape as whatever your base here is. In this case, our base is a rectangle, so the cross section further up along the height is going to be another rectangle, just smaller, and it ends up creating another pyramid with a smaller height connected to that smaller base. So now, going into our theorem, in a pyramid or a cone, we're going to work with some ratios now. So the ratio of the area of a cross section, I'm going to rewrite that, the area of a cross section to the area of the base. So we take our cross section, we put it over the area of our base. This is going to be equal to the square of the ratio of the figure's respective heights from the vertex. So let's go back to what we figured out about ratio of areas. What we essentially have is we have similar figures. We have similar pyramids. And so with the ratio of areas, remember that the ratio of corresponding sides is what we figure out with similar figures. And then as we work into comparing heights, we could also use those as the ratio of our corresponding heights will be equal to the ratio of our corresponding sides. Now in the last unit, we figured out that to compare area, the area is going to be the square of our side ratio as we were in our, when we were working in our area unit. And so now if I compare the area of a cross section to the area of a base, those are comparing areas of similar figures. So I need to set up the ratio of their heights and square them. So in this case, that would be k, the shorter height, to the entire height h squared. And this allows us to do a lot of awesome things. So next up, on our regular square pyramid that's pictured above, let's say that the base edge measures 12 centimeters. So we're going without the cross section. This base edge is 12, and now this is a square. Even though it looks like a rectangle, we'll say this is a square. So all sides of the base are 12. The height of the pyramid is 10, and the cross section is cut 4 centimeters from the base. So that means from the center, this line right here is 4 centimeters upward from the base. So it asks us to find the volume of this upper pyramid. Well, currently there's two things that I would need. I need the area of the base, which is that cross section, C with the line through it, and I need to know how long the height is. So now I want you to pause and think, how could you figure out either of those? I think one of the measurements is going to be a little bit more manageable to find right now. I'll go ahead and pause for a second. Well, hopefully you made the connection that if the whole height of the pyramid is 10, if this was drawn 4 up from the floor, that K has to have a length of 6. So here's what happens next. What we just found is that the cross section to the area of the base is equal to the ratio of our heights squared. And so the area of our base, it's a square, so it's 12 squared or 144. So in order to figure out the area of our cross section, we can use ratios to figure this out. So I'm going to write it in this upper space because we're kind of running out of space below so we can still see the picture. So here's what this means. The area of my cross section over the area of the base is equal to the height of that cross section pyramid, which is 6, over the total height of 10 squared. And now there's one of those numbers that I can replace. I know the area of the base is 144. All right, so let's go ahead and solve this out. This makes our cross section over 144 equals, let's go ahead and reduce the fraction first. That each are divisible by 2, that makes this 3 over 5 squared. So that makes this the cross section over 144 equals 9 over 25. Now let's cross multiply. That makes 25 times my cross section equal to 144 times 9, which is 1,296. And so then divide by 25. And that makes this 51.84, and that is exact. So we'll call this 51.84. And so now we have the area of our cross section and we know our height. So then that makes the volume of this upper pyramid come out to be, don't forget our 1/3, that's important, 1/3, the area of the base, 51.84, times the height of 6. And so then if we multiply that together, that becomes 51.84 times 6 divided by 3. That's 103.68. And then they gave us some units, so we're going to call this cubic centimeters. All right, next up, it asks us to find the volume of this frustum. So next up, what we figured out last notes that we worked with the frustum and surface area is that essentially if you take the top portion and subtract off from the whole thing, it leaves us with the leftovers. So all I really need to figure out is the volume of the larger cone. And so this is the volume of the upper pyramid. So next up, we need to figure out the volume of the lower pyramid. Well, here's the great thing. I already have all of those values that I need. It's 1/3 the area of the base, which is 144, times the height, and the height is 10. So that makes this 144 times 10 divided by 3, which is 480 centimeters cubed. So now the whole thing minus the upper cone would make the volume of the frustum equal to 480 minus 103.68, which gives us 376.32 cubic centimeters. So we did a lot of awesome stuff in that one. We found the volume we found the area of the base using cross sections and ratios. We found the volume of 2 different cones, and then we combined those to find the area of the frustum, which I realized I should have explained this earlier. If you just completely were lost, the frustum is like the trapezoid, 3-dimensional trapezoid shape formed here on the bottom. Alrighty, So next up, I put a couple of extra examples in here that would give you some extra practice. This one here is 2 concentric cylinders, which goes back to our last section. So it's a nice practice problem that if you would like to work this one through, the notes will show this completed for us. But we are going to go on to number 5. So for number 5, it says the area of the lower base in this rectangular pyramid, so it is not a regular square, but it's a rectangular pyramid, is 432 square centimeters. It says that segment DC is 12 and AB, this right here, is 10. It says find the area of CDEF. So here's what we're going to go back to. What we had found is that in order to compare, we can use the areas in order to find scale factors and compare them, but we have to know what the height of each pyramid is, the upper pyramid and the entire thing. So for this upper pyramid, they didn't tell us what the height was, so let's go ahead and draw it in. So from the center of the base up to the top, they do tell us the height of the entire pyramid is 24. So what we can do is we can use a right triangle and connect this across. And when we cut 12 in half, that does make this 6. And segment AB is 10, and that does give us a 3, 4, 5 triangle times 2. And so that makes this height come out to be 8. So now I have something to compare with. So remembering back to our formula, the cross-sectional area over the base area is equal to the height, which we'll call that the upper height over the total height squared. So now we want to find the cross section, and I have all those other numbers that I need. So now we're going to replace those. So that makes the cross section over, they already told us the area, 432, is equal to the shorter height of 8 over the total height of 24 squared. Now again, your life will be made a lot easier if you reduce the fraction before you square it, because 8 and 24 is divisible by 8, and that gives us 1/3. So it's 432 is equal to, and we can just write this reduces to 1/3. Then I'm going to go ahead and square that, and that makes this over 1/9. At this point, we could cross multiply, but I also could just multiply by 432, save a step. So those cancel, times 432. And so then that makes the cross section equal to 432 divided by 9, which is 48. So that means the area of base CDEF is 48, and then don't forget your units, square centimeters. So then lastly, I want you to find the volume of the entire pyramid. At this point, this is a great place to stop, to pause, to try it on your own, to check the answer, but now we're going to go through it before we finish. All right, so the volume of this entire pyramid above, we've got we need 1/3 base, area of base times height. We actually have all of those numbers, so it's 1/3 of 432 times the height of 24. So as we put that in, that's 432 times 24 divided by 3, which is 3,456. 3, 4, 5, 6, kind of like that. And that comes out to be units. It's cubic units, and so it comes out to be centimeters cubed. Alrighty, that is the end of these notes. Hopefully you enjoyed watching the video. I think I've got a couple more for us as we work through other volumes and compare those ratios. For the end of this section, now we have a practice for section 12.5. So make sure that you have section 12.4 practice and 12.5 complete. That is the end of these notes.